Okay, so I think we can start. What I will do is, well, today we will learn a little bit about Python, and I will share. This is the lesson that we will follow, and I will explain to you how to open. If you use Windows, the default is what default. Recommended ways to install Anaconda and then open the Anaconda. You can use either Jupyter Notebook or Jupyter Lab, or even you can use the terminal as we learned yesterday. What I will do is I will share this screen. Let's see if that works. Oh yeah, now you see a beautiful background. So we'll open Anaconda. Here you don't see like this opening is like in another screen, but isn't the when you open Anaconda, I will show you the window. It takes a few seconds to open. Yeah, still opening. So everyone has a window like that with the Anaconda navigator. Please feel free to use the chat to say yes, no, because I mean the beginning is quite important. If we are not in the same page, it will be a bit tricky to follow the lesson together. So once that we are here, we can either open Jupyter Notebook, but here we will use Jupyter Lab. Jupyter Lab is it will open in a browser, and we can use notebooks. So we can use we can edit Python files. We can open the terminal. It's quite useful. So here we click on Jupyter Lab. Well, you see that is working, and this opening is opening here. Well, I think this is because I already have a Python a notebook already open, but you should get something like that when you open a Jupyter Lab. You should get something like this. Hopefully, is this big enough? What you may notice that I'm already in desktop software carpentry Python data, because one of the lesson, if we go to the software carpentry course materials, well, this is the link that we already on yeah, if you're on Mac OS, yeah, you can either open Jupyter. And yeah, please let me know once that you have opened the notebook. So if we click here in obtain lessons materials, we need to download these two zip files, create a folder called software carpentry swc-python on your desktop, and yeah, move and zip the files here in this folder. So it should look like this. If I'm in a moment, and here when you open a desktop, is here you will have this folder and should contain a code and data. In data we have a bunch of CSV files. Right, so once that we are in a Jupyter Lab, first we will start using we can either use, or well, maybe, okay, maybe to make life easier, we'll start with Notebook, but I would like to show you that using a terminal, you can also use I didn't try this terminal. Okay, this is that you type something here in the. Does everyone have opened this window? I'm not sure if I like a switching. Well, let's start. Let's do everyone with the Jupyter Notebook, and later I can explain to you how to. But I mean, everything that we will learn here, you can do it on the terminal. And yesterday, you may remember that we were using a file to save our bash script. You can do the same in Python. You create a file with your Python code, and then you can run that file. Okay, so I will make this. Well, also I forgot to mention a little bit of motivation and why we are learning Python. I mean, the goal of this lesson is, let's say, not to learn. Okay, you will learn Python, but it's more learning programming, how you can create a program. Yesterday we touched a little bit using the Bash, and today rather than Bash language, we will use Python. Why Python? Python is a programming language that is not that old as other languages, like if we compare C, Fortran. And the advantage of Python that is easy to learn, and is quite, when you write a script, is quite readable, contains a lot of libraries that you can use, and you will not need to write the software. Is quite, I find it quite good to develop code in a short time. Python could be used as a big calculator. If we use this, if we execute that, we can type 4 plus 5 multiplied by 5. To execute here, the way is either you can use Control Enter, or if you use Control Enter, you will get like a response, the answer, but you will not get a new cell. If you want to get a new cell, is Alt and oops, it's not Alt Enter, yeah, and then you get a new cell here. First concept that this could apply to any programming language is are variables. Variables are the data that normally when we have some software, we have the data and we have the functions or operations that we want to perform to that data. So at the beginning, we will start with the variables. A variable is the documentation said that is a name for a value. So it could be the weight, quantity, anything that. So when we will start, for instance, using the weight underscore kg equal 60. So if we execute that, in this variable, we are saving the value 60. So at the moment that if we want to show with the command print weight. Also, the good thing of Jupyter, the notebook, if you press tab, it will show you the variables that you have saved. So if you click here and then and you execute that, you will print the content of this variable, that is 60. Talking about the variables, you can use the variables. You see that this can use characters. You can also use numbers or digits, but please don't start a variable with a digit. The variable should start with a letter, and also are case sensitive. If we use print weight.kg, you see that the W is a capital letter. Also, I didn't ask, is big enough the font? Please let me know if I can make it bigger. So if you try to print that, we will get our first error. This is another thing that I like of Python, is normally the messages are quite explain to you what is happening, or are quite they contain a lot of information. So here we have the type of error, that this is a name error, and also here you have in our case we have only one line of code, but in case that you have more than one line, it will indicate in which line is failing. You get the name error, so it is telling you that the name weight is not defined. So because this is a case sensitive. And types of that we can save, we can save integers, that is could be 60. We can also save weight kg could be like 60.3, so we can save a floating point. And now if we print, we will get the new value. Oops. And also we can save for instance, patient name equal And if we print patient name, you see that is we have that string. So these are the basics that we have: integers, a floating point, and strings. We will see that we can later we'll see that we can also save data sets, arrays, but yeah, let's go step by step. And again, this is like if we use other programming language, we will have variables, and also we will have types that these basic ones like integer, floating point, or strings. We have them available. Before we started using an arithmetic operation, but we can also use the variables to if we want to calculate the weight in pounds rather than kilos, we can multiply by 2.2 the weight in kilograms, and if we print, oops, you see that yeah, the value of weight in kilograms has been multiplied by 2.2, and we get the weight in pounds. Here there is a, well, not sure if it's a trick or not, but this is like a question of if I use let's update the weight in kilograms, and I will use 100. So if I print now the weight in pounds, what the value will be? Will be the same as of this one, or it will change? You can type the answer in the chat. So yeah, this is one thing that if we print the value, yeah, the value is the same, because when we created this variable, we have used the value that weight in kilograms have at that moment. At that moment was 60.3. If we update the value in kilograms, it will not update this, because this has been like already done. Hope that it makes sense. You are getting here, when you do this operation, you are getting the current value of this variable. So if this variable in the future is updated, is not updated let's say this one. You will need to redo this operation again. So we can copy cell. Okay. In theory here is well, to paste the cell. You will need to do it again. And now when you print weight, you should get 220. Well, here because we are using you see that we started soon getting this because we are using floating point numbers. Floating point numbers, the operations, so they have a small precision error. So you see that rather than 220, you get 220, but you see that you get this small error here. This is also important when you do a lot of floating point operations. So bear in mind that there could be like a small error, like this one. When I use the function print, I'm just using like one. I'm just using one parameter, but you can use more. You can use patient name. You can separate the values using commas. Do something like that. Wait. So well, here I'm putting a space, but normally between like elements, you get like a space. So here we get like a double space. Okay, I see in the chat that there is an issue with the. Sometimes it happens. You need to restart. Would be good to restart the browser, and you may get the sound. Or maybe you have a muted it, but yeah, happened to me before with the Blackboard Collaborate. Normally it works well, but yeah, sometimes it has like some issues. Okay, what else we can do with the, well, we have seen the variables, and we can also see can print the type of the variables. So if we print the patient name, and we can print the type of weight in kilograms. We execute that, we see that the patient name, the class, is str, that it means a string, and the weight in kilograms is the class is integer. And if we print that, I forgot to print the type of weight in pounds, the class is a float. So these are the three basic types, classes that we can have. Okay, well, last thing before we move on, comments. Comments is like yesterday you remember that we used the hash key to start a comment, and in Python is the same. You can use print a variable and then print something like that. Oops. Oh, yeah, that I'm using this variable that has not defined. So we fix that. Okay, now it works. Any questions regarding that? This first part is about the variables. Basic ones, we have strings, we have integers, we have floats. We can do arithmetic operations with them, and we can use the variables also to do arithmetic operations. Okay, so now what we will do is we will move on and we will start working with the data. I think that will be useful to show you the data that we will work with. I think it's here. You see my, I have too many windows open and yeah. Perhaps. So here, if you have downloaded the data, we have like several CSV files. Yesterday I explained that a CSV file is well, the CSV comes from comma separated values. So you have the data, each row. You have the data in rows, and to cover the columns, each column is separated with a comma. And what we will do, this is a medical study of, we have some inflammation data. Here you see a representation of the data. So you have a patient, each row will be a patient, and I think we have a total of 60 patients. And each column will be a day, because the study will be over 40 days. And what you will have is the number of inflammations per day per patient, let's say. They call it here, let me check the flare-ups, because this is like for to study like the effect of a medication. And over a few weeks, the treatment of the whole disease gets solved. So we have this data here, and what we will do is we will do some analysis. So we will get this graph that we will learn how to create this graph. And once that we have the graph, we can reach a conclusion, and we can reuse the graph to write a paper, etc. Okay, so let's start. So if we move here, I will need to, well, you see that in my in Jupyter Lab, I'm in one moment that I have a lot of windows open. Only this one. Yeah. So you see that I'm in desktop in software Python and data. Is everyone else getting like sound? Because I see in the chat that some people are not. Oh well, like one of them can't hear me. Okay, so yeah. I don't. Yeah, sometimes I don't know if I'm talking on my own or you are listening to me. Okay, so I will. Continue. So I was talking before that we can use libraries to libraries are a set of functions, and also like some of them they have some constants that we can reuse. So one library that we will use now is NumPy. So to use a library, we will need to use import NumPy. So if I execute that, if the all works okay, you will not get any error message. Could be the case that you get an error message, and this could be because the NumPy library is not installed. So now that we have the NumPy library, we will load the data that we will use today. So to load the data, we will need to use NumPy dot and the name of we need to use the name of the library dot and then the name of the function that is load txt. We open brackets and we will use two arguments, the name of the file and also the delimiter. Because it's a comma separated value, we will use a comma as a delimiter. So fname will be equal and the name of the file, that this is inflammation. Also, if we press tab, we see all of the files that we have here. So this one, comma, and the second value will be the delimiter, equal, and it will be a comma. I close the bracket, and if I press Alt Enter, you will get something like that. You will get that this array of values have been loaded to memory or to the yeah. So did you get any error? In case that for some reason you have an error, it could be that you are not in the folder data that we have downloaded before. Like this. Did everyone manage to load the file? Yes, no. Please use the chat, otherwise I don't see if where you are, if you are making progress, not. Great. One thing is that yeah, we have loaded, but we haven't saved the data in a. I made the mistake that I didn't save the data in available. So let's fix that. Well, actually, I don't know if, what we can data equal numpy. Well, you can also copy and paste. So you select here, copy, paste, Control C, Control V. One advantage here is that because we are using each argument has a name, we can change the order. We can do something like that, and we'll see if that works. Well, now it's not showing anything, but we can also add a print data. So when we call a function, if we specify the argument in this way, we can change the order of the arguments. And now that we have data loaded, we can play with the make this maybe a little bit. So what we have done so far is just in data loading the CSV file. And now we can perform, well, one operation that we can do is to see the type of data that we are using. So as you see that we are using now a more, let's say, complex data type, that this is a NumPy and the array. So like and the array stands for n-dimensional array, because you see that we have some rows, and each row has like several elements. So we have what we can call it a matrix or to the array. If we want to see the data of the elements, we will need to use print data.dtype. And we see that we have a float 64. Before we were getting float, but 64 means that is use 64 bits to save each number. So we will get a higher precision when we do the arithmetic operations. Another value that we can use is print data shape. If you notice here, data is the variable, but the variable itself has some, when we use the dot, we have like some properties, or let's see some, one of them is a d type and another one is a shape. So for shape, we have 60 rows, 60 patients, and 40 columns. So 40 elements per row, let's say. Okay, here is a question. If I want to print the first day for the first patient the first day, how can I do it? I will start print. So let's say first day, first patient. I will need to use a square bracket and say the coordinate of where the data is. So is the following correct? If I do this first day, first patient, and I get 1. Is that correct? or do you think that something is not correct? Is correct if we were using, let's say, Fortran MATLAB, that the first element starts with 1, but Python comes from, let's say, let's see, the C family, or let's see that the first element normally is a 0 rather than 1. So to get the first patient, the first day of the first patient, we will need to use a 0 rather than 1. So if we execute this, we will get first day, first patient, we will get the value 0. That actually, when we see the matrix here print, we'll make this a bit bigger. Yeah, we see here this value, that this is this one. Okay, so what else? So we can do a slicing. Slicing means getting a subset of the, in other programming languages, like let's say C comes to my mind. It's a bit of a nightmare to get a subset of a matrix, but using Python actually is quite easy to do that. Let's say that we want to get for the first 4 patients and the first 10 days. So the way of doing that is data. Again, we use a square bracket, and we get this will be the first 4 patients. We use a 0, will be the, let's say, the first patient, and then is up to 4 without including 4. And then we want the first 10 days. So it's again from 0 up to 10. So if I print that, here you see patient number, the first patient, second, third, fourth, and you see also the first day, second, third, fourth, fifth, sixth. So, in that case, you can get. You will see later that if the value is 0, you don't need to use it. I mean the index. So if it's you can do something like that. And will be the same. Oops. Okay. Well, okay, now I explain. I get the first 4 patients, is okay, but if you notice here, I saying like from the day the day number 9 until the end. So I get you see that the 3, 6, 9, and 7 are here. Okay, well, yeah, get like the next element. That will be 3. This 10 will be here, the next element of here. 5 will be the next element here. So this is let's say until the end of the array. That rather than writing here that you can also write 40, you don't need that. And also you can get like if we want the patient therefore you can use something like that. I mean, you can specify the range. You specify the range with a column. So before the column is the starting number, and after the limit of the index. And remember that for indices we use 0. I mean the first element is 0. Any questions so far? And also this slice, you can save it in a variable and you can perform operations. So okay, more things that we can do with the data. We have a bunch of numbers and we can get the average, minimum, maximum. So for that, we can use NumPy. So if we do print numpy.min to get the average, you see that the average of all the inflammation, let's see the average number of flare-ups is 6.14875. And one thing that you can calculate the maximum value will be equal numpy.amax you may notice that rather than max, I'm using Amax. This is because in Python there is another function that is called max, and NumPy rename using Amax in order not to make to confuse users. But you see that here we're using the name of the library and dot and the name of the function. So min to calculate the minimum will be the same, min equal numpy.min data, and also you can calculate the standard deviation. numpy.std data. And with these values, you can print max var to make is copy and paste minimum. So if you execute that, which ways you will get in our data the maximum number of flare-ups will be 20, the minimum will be 0, and the standard deviation is 4.6. There is also a way, if in case that these three assignments, we can make them in the same row. So the way to do that will be like a max val val td val. And you can assign with the commas, with commas, this minimum. And if you copy and paste from here to here, you see that yeah, works the same. This is in case that you want to define these three variables in one line. It's possible. So this will be this. The second value will be variable will be this, and the third variable will be this one. Any questions? So the one moment, yeah, I think there is like a question in the chat to. So the data that I'm using is here. Is in if we go to obtain lessons materials, is here data, and we will need this one. I will copy that in the chat. As I said, if we want to make to add some comments, we can do them. We can use the hash key and then say a print max and let me check that. Also, in case that we want to see because we are using NumPy, when we press dot and we press tab, we can see here all of the functions that have a max, a min. You will see that they have many, but here we are just using like a small set of functions. But you see that the libraries like have plenty of functions. And to see about to get some. Let me check if Emacs was like a. So to get help, you can use the function help and write the name of the. So they tell you also the here we're using, you see that we use data will be the argument A, but also we can use the axis out. You have all of these info on the. And also you get equivalent method that and the array.max. I think if we do print data.max, okay, because it's a function, I need to specify the bracket. So there are two ways of either using numpy.amax and the value of data. The other way is data.max, and I think max should work as well. So if we print yes, you see that we get the same. Actually, yeah, these are the same. In the documentation is Amax used, but max could be used as well. So are different ways giving data as an argument or just using data, and because data has this is I'm seeing a variable, but well, actually this is an object, and the object has these functions with. Oh, okay, that's yeah. To get the list of variables is if you go numpy dot and then you need to press tab. When you press tab in your keyboard, you get all of the functions and the classes, modules, everything that is available here in the. Also, if you go to like a here, if numpy, here you will find a lot of information of documentation, user guide. Oh, it's in PDF. The API reference is the. So also here you have all of this information. Because we are using the n-dimensional array, here you have like an example as well. If you see here, for instance, you can specify the type of, by default is getting float, but we can specify it int 32. We can get elements. So for instance, here is quite useful to learn the shape. So here you have that's the advantage of a Python, that the documentation is quite good, and if you go, you get functions, so you get samples that you can copy and use in your code. The keys, the tab is the one that is on the how to explain that. I mean, depends on the keyboard. Is in my keyboard is on top of a caps lock. So normally I tend to use it quite a lot when programming, because to yeah, in yeah, I see that yeah, also in Mac the keyboard is different. So I think I can use. You see if I. Oh, this is an Apple. So yeah, this one is if you press this one, you get the 99 pounds. Cool. So yeah, also like when I write, I was using like a patient. Normally, if I press tab, I get the rest of the name, so I can use it and save typing it. Or if I want to load the file in Flame, I can also get this. These are nice features of the Jupyter notebook, but also we can see later that you can use Visual Studio, for instance, to write Python. There are a lot of developing environments that you can use. But you could be the case that if you use a remote machine, that you don't get access to a notebook. In that case, it's okay. And actually, that's why we learned yesterday how to use the command line. Using the command line, you can use Python as well. Everything that we have seen here, you can do it in the command line. Later, we can see an example. Okay, so I'm talking about the maximum, minimum, etc., but I'm getting the maximum, minimum of the whole data. What if I want the maximum or minimum per patient? That is a way that the way is if we use numpy dot let's say the maximum of data, we can specify the axis that if we want per patient will be the axis 1. So now if I press Alt, I don't know why it's Alt Enter. This is for the patient, for the first patient, the maximum is 18. For the second one is 18, 19. And in case that I want the maximum per day, I will need to use a different axis, axis 0. So let's say numpy max data axis 0. So the maximum in the first day is a 0. For the second day is a 1, 2, 3. You see that it increases until this and then decreases. So it's increasing until here and then it's decreasing. So okay, see that there is a question that what is the difference between a max and max? Actually, there is no difference. It's are the same. In NumPy they use Amax because they want to in Python there is a function called max, but this function is different of numpy.max. So in order to avoid let's say mistakes, they say that Amax, but also they have an alias. Actually, I think to make things easier, maybe they make them more confusing. So yeah, short answer are the same. And actually I learned that with the help that they were. Oh, okay, that's okay. This is longer than. Well, here is explained about the axis. What it returns. Because I'm printing. Okay, I'm printing max. But here you have. Also, the good thing of the documentation that they have some samples that you can use here. And a tricky thing that I always, maybe there is a trick over there to remember that axis means columns, and sorry, axis 0 is columns, and the 1 is rows. Maybe you think like like a coordinate system. But yeah, I confess that I always struggle to remember axis 1 or 0 if it's rows of columns. That's why we have a Google, or maybe to take note somewhere else. Okay, so this is regarding yeah, this is what I wanted to talk about, like this episode of NumPy. Any other questions? Should I continue with the plotting? Yeah, let's continue. Okay, so we have seen the library that is NumPy. We will see now another library that will be for plotting. So the library is matplotlib. That matplotlib here we will see like a very small part. I mean, same with the NumPy. NumPy has plenty of functions, and same with the matplotlib. Here we will see like just like a small part of what we can do with the matplotlib. So if we do import matplotlib, also we will use a pyplot. That is kind of a, let's say, a library inside this library. We will use image equal matplotlib dot pyplot. I am show data. Then matplotlib dot pyplot dot show. Also, I think that they haven't explained that you can call a function with arguments, and there are other functions that they don't need arguments to run. So if you execute the following piece of code, you will get this kind of a heat map of this, well, yeah, the representation of data. If you remember, we have 40 columns, so are 40 days, and we have 60 patients. So as you see that the inflammation flare-ups in the day 20, say 21st or well, actually this would be the day 19. You see that yeah, there are like some yellow. That means that yeah, there are like a few of them. But at the beginning, the day, the first day, at the last day, there are no, let's say, inflammation. So you have like a dark blue. So this is like in case that you want to generate a heat map. But we can do as well. Before we were talking about the maximum, minimum, etc. We can plot when we got this. Sorry, scrolling up. Here you can get the maximum, or here you can see the evolution of the maximum. But here you see an array, you see a bunch of numbers, so it's a little bit difficult to spot what you, let's say, to read the data. So in that case, it's better if you create a graph. So let's do that. We will start plotting the average inflammation. So we will create a variable, average inflammation, that the variable will contain numpy dot mean data axis equals 0. Okay, that's a good question. I see a question in the chat because we are using matplotlib. This is like a print, let's say inline is printing the same. But if we're using the Windows shell, when we execute this function, what the function does is open a new window with our picture. Actually, later we can do a quick test and see if. So I see that some people is not getting could be yeah, later we can have a look. Yeah, I see that this part could be tricky. I don't get any error, so yeah, this is about you could be the case that yeah, it's not working. It's not plotting here. I'll have a look later of them. Okay, so to print the average inflammation data of per day, we have the array that we want to print here. Let's save the plot here. That would be matplotlib dot pyplot dot plot. And here I need to specify what I want to print. That this is I want to print this array. And now I need to, I think this is for, I think this is like for when we use the Windows shell. If I execute this, I get something like that. I give you a moment to type the. everyone is getting this. I see in the chat that yeah, so could be the, I don't know if I said could be the version of it's not working because of the version of could be the version of Jupyter, or I don't know. We can have a look later in the maybe during the break. Okay, so here I'm generating the average, but I can generate also the maximum, minimum. Okay, well, let's do like a quick exercise. Would you mind like using the same code, generate the maximum and minimum? Let's do this exercise, and we have a break at 11. So I think yeah we can yeah I'll give you a few minutes and we can share the solution at the end of I mean before the break that is at 11. Also, any questions, please let me know. So yeah, using the same code, generate a maximum and minimum plot and see how they look like. Okay, so before going on for the morning break, let's generate. I will generate the maximum. Actually, I can let's. So as you can be like a laser copy and paste, and it's a question of editing. Max inflammation will be we can use max or a max. So me rather it will be max plot, max inflammation. This will be the same. So here's the representation of the maximum. And if we have the minimum, I think there is a way to create a duplicate. Let's do that. And again, we'll do the minimum. Inflammation, min, here, min. One of the dangers of copy pasting is that you may forget to rename a variable, or a risk that sometimes we have to. And here, okay, I see that it's a different minimum. Also, you see that the x-axis is the 40, because we have a 40 days, fine, but the maximum change, the y-axis changed. Here, the average is, the maximum is 13, so you have this. Here we have a maximum of 25. Later, after the break, we will see how to use the same y-axis, the same let's say range, because if we compare these three plots, could be a little bit misleading because they have a different y-axis. Yeah, see a question about the outputs on the chat. The problem of collaborate is a little bit the limit, so you cannot share images. Well, you can share the code, but yeah. Okay, so yeah, we have made good progress with the lesson. We have learned how to use variables, how to use NumPy, matplotlib. After the break, we will continue with the matplotlib, and also we will see how to do this using the terminal. And I think now, yeah, 11 is a morning break, half an hour. So please stand up and have a coffee, tea, water, and yeah, have a small break, and we'll be back at 11:30. Hello everyone, you're back. Can I check if the audio is working okay on your end? Okay, thank you for checking. One of the attendees had an issue with the audio. Hopefully it is solved now. If not, as I said yesterday, these sessions will be recorded and can have a look later. Okay, so what I will do is I will share the screen. Yeah, one moment. Okay. So I can make this a bigger. Oops. Yeah. Okay. So one moment. Let's check where we are now. Okay, so what we have seen so far is how to use matplotlib to generate these graphs, plotting the maximum, minimum, and average of. So what we will do is we will do it in a because indeed this is like a difficult to because these are like a plot ones. So we will plot the three graphs on a row, and we will do some exercises based on that. If you go here to the, let me see if I can share that with you in the chat. See, there is a question that about the average. Yeah, the average is we're using you're using data and we are using the axis 0. So we're using the average per column per day. So the average of the day in the first day is this one, in the 4th days, 5th day will be this one, 10th day will be this one, etc. So it's per day. So if you go to that link, you will find the code that I will generate here. I will type here. So actually, this will be a script, and we will save the script in on a file. I will start typing the code in order to have a plot, to have the 3 plots in the same row. Yeah, I see a question in the chat. If we use axis 1 is average per row, so yeah, will be average per patient. So import numpy, import matplotlib, pyplot. We load the data, so it will be numpy load txt and the delimiter. We'll create a figure that will be matplotlib, pyplot, figure, and as a parameter I will specify fixed size equal. I will make it 10 and 3. 10 will be the width, and the height will be 3. No, sorry, the other way. Ah, yeah, see, yeah, something like that. Oops. Why? Ah, okay, because I didn't close this one. So what I will do here, I have a figure, and I will add 3 subplots that we will call it axis 1 equal fig dot add subplot. And here I will need to specify the layout. The layout will be like 1 row, 3 columns. So it will be 1 row, 3 columns, and the position in the layout, that will be the position 1. And I will do the same with the other 2. Later, when you see the figure, you may understand better then. So 2 and 3. And I will start editing so for axis 1, I could set the Y label that will be average. And also I will set the plot. So plot will be numpy amax data, and axis will be 0. And I would repeat the same for the others. So axis 2 will be max. Oh, sorry, I said here average. So this is the first mistake. Will be mean. Max mean. Max 3 mean. Okay, I think all is okay. Mean. Fig tight layout. And what I will do is I will, well, let's go step by step. Let's do matplotlib leave pyplot, no, pyplot show. So if I execute that, in our case, because we are using already the Jupyter notebook, I will this. Let's see that this is already done, but well, just to make things like more, because this script we can copy that on a file. Yeah, let's make things like more, let's say more for completeness. Let's have these three operations here. So if I execute this with the with the Alt Enter, we see that we get everything in the same row. We get average, maximum, and minimum in the same row. So exercises here. Let's give some time for exercises. The first exercise will be change the scale of y-axis. Using this function, I will make this. Yeah. Oh, well. The second one is second exercise. Add the standard deviation and change layout. I will actually copy this here. Okay, here you see the whole code. So let's do these two exercises. Let's change the scale of the y-axis in order to have like the same scale for these three plots. And the second exercise is add another plot, a standard deviation, and change the layout to 2 by 2. And once that you finish the exercise, please let me know. Okay, so let's solve the exercise together. Before, one thing that I would like to show you is how to run this on a, because here we are using a Jupyter Lab, but in case that for some reason you don't have access and you have access to a terminal, you can do so. I mean, to show you that, I will use a Jupyter Lab, but yeah, let's go step by step. So the thing, this is a Control C. This is like a whole code. So this could be saved into a file. So I will copy also the comment. So here, if we open, if we click in Jupyter Lab Python file, I can copy this file, this text, and I can save it. If I press Ctrl S, I could call it plot.py. If you remember yesterday, we were using extensions to make life easier to the operating system and for us to know what the contents of the file, what are the contents of the file. So we are using py. So this is a save. And now if I'm opening a new tab and I'm going to a terminal, also will change the settings to make this, otherwise will make a Jupyter Lab dark. You see that I'm in a terminal, and also you see here, this is I'm using PowerShell. No, I don't remember if PowerShell has a ls. Also, you see if I do the ls, you see the files that I have here. So I have a file called plot.py. So the way of running that, if I do Python plot.py, it should work. And you don't see the, okay, give me a second, because what I will do, I need to share my whole screen. Yeah. One moment. And so when I'm in the Windows shell, I get a new window open. And with that's why we are using, when we are using here, this function, what it does is open a window that is this one. So when you are in either in your laptop or in a remote system, actually what I do is I do that. I use the terminal normally to run the, and actually we will solve the exercise using that. I close this window and I will, I need to open my file that is this one. So I have this. Okay, first exercise is change the scale of the y-axis, and the hint is using the y-limit. How to do that? Let me think. We need to change it for each. So let's copy this. So a minimum we can, because we know that it's 0, we can be clear, say, okay, let's set a minimum 0. And well, the easy way, let's say, okay, let's put let's say 20, because we know that the maximum is 20. We save it, and then we'll move to the terminal. And if we run the code again, you see that now for sorry, we'll make this. Is it more readable now, the code? So if you see I made a, well, see that I made a mistake. This is what I mentioned before, that this is one of the dangers of copy and pasting. because I'm modifying 3 times axis 3, but I need to modify axis 1 and here axis 2. So if I save and I run I need to close this window. The problem is I don't know why here this is like in yellow. In a yellow color. Maybe what I can do, I'm not sure if this could be view. Let me see if I can split the. There used to be a way to split the. I don't remember now how it was. Split the screen. Okay. No, I cannot do. Oh, I can close this one. I mean, I split the screen and then you can see the code all the time and you can see what I'm doing with the. So if I do Python plot.py, you will see that now the code works. I have like what, yeah, 20. I have 20 in the three. But the problem here is at the moment that I'm using inflammation of one, but at the moment that I use another set, it will not work. So I should like do something more clever. So rather than getting a 0 and 20 like specified by hand, I can define some variables like could say something like maybe I don't know, min y and max y, and here I could say data max, sorry, will be minimum, and data dot max plus 1, just to give like some room of. So here, rather than 0, will be min y and max y, and the same. So if I have that, I should close this window here, and then I need to save the file with the Control S. Here you don't see, but yeah, I'm using like a Python plot.py, and let's see what we get. Yeah, we get something like that. This is regarding the first exercise, that is changing the scale of the y-axis. Is everything clear here? Have any questions or? Okay, so this is for the first exercise. For the second one, we can either make a copy of this file. Actually, we'll make a copy of, if we go to the file browser, can copy, paste, and have a rename. Plot, plot row, for instance. And what is the name of this file? Sorry, I don't see the plot copy. So plot square, I will call it. And I will open this file. Okay, so I'm using plot square. Let me think. Okay, I want, so if let's go step by step. What we want to change is the figure size will be a okay, let's use 10 by 10 because this will be a square. And rather than 3 axes, I will need a fourth one. So it will be axis 4 equal fig dot add subplot 1, 3. Well, this will be fourth. But if you see here, I will need to change the layout. Before we were using 1 row and 3 columns, and here what I will need to do is to use 2 by 2, 2 rows and 2 columns. So we have a 10 by 10 and 2 by 2. We keep the same, this will be the same. So we have axis 1 average, maximum, minimum. Okay, so we need to add here axis 4, set y label std, axis 4, set y lim, min y, max y, axis 4, plot numpy std data axis equals 0. So in theory this should work, but we'll see. We'll save the script, and now here in the terminal we will type. Sorry that this is like a yellow. I don't know why this is Python plot underscore square dot py. Well, this is opening in my other screen, but I can move and I got something like that. If I'm not happy with this, yeah, it looks like a bit of a square. If I want to make it like a, maybe I will change that and make the height, this is like a 10 by 10. I don't remember, but well, let's try 8 by 10 and see how. This is not what I wanted to do. Okay, it's not a problem. Just 8, 10. Save, execute again yeah, okay, this is what I wanted to, yeah. And one thing that I haven't explained, that this is in the documentation, is how to save this, how to save this figure on, in order to use it for a paper. So the line is matplotlib. This is in the documentation. So pyplot.save figure, save fig, and I will save it in a PNG format. Inflammation.png. Let's see if that works. So if I execute again python plot_square.py, I see this result. For instance, if I'm connected to a cluster and I don't have like let's say the graphical output enable, the X, maybe the last line doesn't work. But now if I do ls here, you will see that I have this file, inflammation.png. If I click here, oh yeah, it's open here. Oops, there is no way to make it. So the recommended way to let's say to use Python, in my opinion, is to have you have a file and you make modifications to that file, and once you're happy, you can save the file. And also this file, because it's plain text, we will see on the Friday that we could make a copy and upload it to GitHub. And also it's easier for to share the file. Yeah, this is my recommendation. The Jupyter notebook is good to play and debug and get, but for instance, with that you can also play, and you have a window with your code, a window with your terminal, and it's just a question of running the script and checking that the output is correct. Any questions so far regarding this? All good? I wanted to one moment to see if I see the I see that once you have an error, maybe my colleague Luca can help you with to debug the issue. Also, the solution to that exercise is on the documentation, like in some. Not sure how can I share the. Okay, now it works. Great. Okay, before we move over the last, when we use a plot, we have plenty of options that we don't cover here. We can change the color of because if you remember it's blue, but we can change the color. We can change the thickness of what we plot, add a title, Y label, X label. We can do whatever we want. And one of the options that are in the documentation is to use draw style, because we are using a straight line, but we can change and use, if we want, here like will be draw style equal steps need. So if we do this for each plot, I'm copy and pasting. I will copy that in the chat in case that you want to copy and paste. So if you do that, and then now just save, and we run again the script, you see that rather than getting a straight line, we got this way of uploading the, and maybe it's easier to see the increments, or yeah, maybe. I think here if you press save the figure, you can save it as well, and you can choose also the option that you can save it in all of these formats: JPEG, APS, PDF, PostScript. Yeah, this is quite useful when you're writing a paper. You can generate with a few Python commands good quality plot. Okay, let's close, and next will be to keep learning about okay, next that we will see is how to use lists of we have seen concept of variables, NumPy, Matplotlib, but yeah, let's play with how to generate a list. So what I will do is I will close this. I think I can, yeah, oops. Close this. And I will move to the, yeah, to the notebook. We'll make this maybe bigger. Okay, so a list, how to create a list. A list will be saving a variable, like we can create a list called odds, and we can have a list of numbers. List is in square brackets, and the numbers could be 1, 3, 5, 7, and we can print the list like that. Also, to get the we can get an element of, or the first element of the list, print first element will be 0. You remember the first element is a 0, so I mean, yeah, rather the index of the first element is a 0. We can also print last element. Okay, this is interesting here. The last element, we know that we have the length is a 4, so the last element we know that this is a 3. So, well, this will be like the, let's say, non-portable solution. So yeah, we get the first element that is 1 and the last element that is 7. But what if the list change? We can use odds append 9. Print odds. If we use that, you see that Now the odds is 1, 3, 5, 7, and 9. We have 5 elements. So if we execute this again, it will not work because the last element now is not. Actually, I can duplicate. I think I can move this. Yeah. So how can I solve that? To reference the last element, I can use odds, or what? No, the function length odds, but this will fail because the length is 1, 2, 3, 4 is a 5, and the index, remember that it starts with a 0, so it should be odds. Well, we get the index error that the list index is out of range. And as what they said, when we have several lines of code, there is an arrow that points us to the line that fails. So this should be like a -1. So if we do that, now it works. First element 1 and last element 9. Easier than this is, let's copy, just do this. Use a negative. In some programming languages, you cannot use that, but in Python, you can use a negative index. That means the -1 means the last one. It's like a cyclic. If imagine that, yeah, this index is 0, -1 will jump here to the 9. So if we execute this again, you see that the last two operations are are similar. Sorry, similar. We get the same output. Here we get a list of numbers, but we can also get a list of names. It could be could use like a Juan, Luca, Eleanor, just to make this sample different from the documentation. So if I execute that, and then I now print names, I can also print names 1. Oops. Okay, you see the error here is a syntax error because I have a closing parenthesis here, but there is not an opening one. Well, actually it doesn't match this one. It's because this one should be, yeah, not a square bracket, but a bracket. So, oops, I'm getting the same. Because I didn't delete it. Sorry. So you see that, yeah, these 3 names, and yeah, the second name is Luca. So for instance, if I want to edit one of the elements, I can do that. If I want to, for instance, in my case, I want to add, I don't know, my middle name, let's say, you can use name 0 equal 1. And if you print names, also this will fail because it's an MSN. Yeah. You see that, yeah, I can modify elements of the One thing that this is in the documentation, but well, you said maybe it's not that. You can modify in a list. You can modify elements, but you may think of like we have used before patient ID, patient name. Let's print Juan, or what you can define. Let's to make this more. Juan. But if I noticed that here I use a small j rather than a capital J. So if here I use patient name 0 to modify the first, let's say the first character, and say J, if we run it, we will get a type error. We get another error here. That again, yeah, this is the line that failed, and said that the string object does not support item assignment. So when we create a string, we cannot modify it. This is not like in other programming languages, a list of characters. It's like a, yeah, you cannot modify the elements here. You will need to reassign the whole string, let's say. Okay, there is also another interesting thing in the well, with Python or with programming languages in the documentation, that is let's make let me think in the sample. Imagine a recipe. The recipe will be lemonade, and the list of ingredients will be lemon, water, and sugar. Let's print the ingredients. That would be lemonade. So if I execute that, we get the lemonade ingredients will be lemon, water, and sugar. Right. But I see maybe some people, yeah, with sugar we can make a light version of lemonade. So we can use, we can make a copy. So it will be light lemonade equal lemonade. And in the copy, we can do light lemonade. The ingredients, the last ingredient. Actually, I can use -1, but well, let's use 2. This will be like yeah. We can use we can use oops, here. I'm not sure if this is like in a second. Okay, sweetener, whatever that is. So now let's print the both recipes. Now print light version. We can delete these. Oh well, let's make So okay, let's execute these. Okay, what is happening here? What is the error that we are getting here? I will delete this to make things simple. We see that the lemonade ingredients and the light version, the third ingredient is same. This is because when we copy, we are copying the lemonade here is a pointer, is pointing to this list. So when I use like lemonade equal lemonade, it's like both variables are pointing to the same position in memory. Because I'm not creating a copy. Both of them are pointing to the same position in memory. To avoid that, you will need to make a copy of the list rather than just copying the. I think this is done with the lemonade copy. If we use that, let's see if that works. This works because we see that it's yeah, here we are creating a copy of the list, and now we can modify in different positions of memory. Is that clear? Any questions regarding that? Let me okay, let's make another. Let's remember the contents of odds print. Okay, we have this, so we can. So we have seen how to use append, but also if we use odds and we use a tab, we see that we have append, we have copy that we have already used it, we have a pop, remove. I think there is a way, let me check if that works. Okay, also if you put the like a interrogation mark, you get here some the docstring that we will see tomorrow how you can define it. So by default, you get the index -1, but if you define the index, you can get the. Okay, so if I want to delete or to pop the first element, so we will remove element alt.pop with the element 0. If I execute that, this function, what it does is remove and return the item at index where default last, that is like a -1. There is also remove that I don't remember. Let's see how it works. No. Remove, what it does is remove the first occurrence of a value, so it's different. So pop, it depends on the index, but here it depends on the value, the first occurrence of a value. So this is also another way of learning the different options that we have in our lists. Let's make this so again print out, so I don't remember. So we have 3579. We can also use a slicing here. So we can do print, actually, sorry, we can do 1, 2, so we print the 5 and 7. Oops. Okay, to print 5 and 7 should be like a 1, 3. Because the thing is, you print 1, the index 1, you print the index 2, but the index 3 is not printed because this is the maximum here. So in that case, you printed the first 2 elements. Later, well, tomorrow when we learn a little bit more about the for loops, we will see how maybe the equivalent of using a for loop. Okay, and let me see if I forgot anything. Yeah, I think it's all the same. But okay, we have 15 minutes. What we can do? Okay, I think we have time to explain the for loop. Okay, let's do that. I will explain the for loop. I will send you an exercise, and we can see the solution tomorrow. You remember from yesterday that a for loop in Bash share, the for loop was for element in list was do an operation here. Another operation, and then done. This was the syntax of, I think I can, well, yeah, this was the, if using bash, the syntax was that, if I remember right, from element in list, do this. And this is when we have a list, it's like I iterated through the elements. How this could be done, actually I will make this in a comment. How the same can be done using Python. So in Python, the syntax of a for loop is pretty similar. It's for element in list. Remember that you need to use a colon here, and when you press enter, you see that you have an indentation here. Normally, by default, here is using four spaces, but you can modify that in the settings. This is a question of style. I think default is some people use 3, 2, 4. It's a bit up to you. I don't remember now the standard. I think maybe the standard is 4, but yeah, I don't. This is like maybe one of the issues of knowing several programming languages, that you start like mixing. I mean, concepts are similar, but yeah, sometimes it, as you see, for instance, using Bash or using Python, it changes. So this is using Python. And here you will do like an operation. Another one. Oops. And the way of exiting the for loop will be to delete the indentation. So this operation is outside the for loop. So the way of knowing that the body of a for loop is because you have a use for spaces. I will comment also this as well. Right. What we can do using we can do for element in odds, we can print so if I execute that, we print 3, 5, 7, and 9. So I'm going for each element in odds, I print the so this is the way of running a for loop. Let me check if I'm yeah. So yeah, this is the for loop. So there's the I don't know. I didn't explain this to make the exercise. Well, okay, I can explain this for the exercise that I want to do. Is clear the for loop? So if it's clear, the because I mean the exercise that I want to do is the apply or use because we are using inflammation of 1, if you remember, to plot, but we have other files here. We have, let's make this bigger. You see that we have an inflammation of 1 or 2 or 3, 4, 5, 6, 7. We have all of these. So the exercise is using a for loop, generate all of these for each file, generate the graph. In order to do that, to get the list of files, you can use this library, import glob. And the list of the file list will be glob.glob, and the name will be inflammation. Remember yesterday of the asterisk that we use to have like a let's say sort of element like a wildcard dot CSV. So if I execute this, well, let's print the file list to see if that works. You see that here I get an array of a list with inflammation of 1, inflammation of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So with that, the exercise is to print the will be or generate and the way will be like you can do for in file list so yeah, here you print the name of it, but I don't want to print the name. Well, okay, you can print the name, but I want to generate the plot for each. So this will be exercise. We have 6 minutes left, so you can try now, but also I understand that maybe it's very close to lunchtime. But yeah, I'll be here until 1 p.m. and this will be the exercise. Edit the, maybe you can create another, you can use a plot all, for instance, and you can edit the file and do this. Okay, 1 p.m. lunchtime. Thank you for joining to this Python session. Tomorrow we will see the solution to this exercise. And yeah, have a nice afternoon. And also, if any questions or anything this afternoon, please feel free to contact me using my email address. Bye for now. Yeah, see you tomorrow.